Hello everyone. Now we are going to discuss about the optical isomerism. Before going to the topic, we have to know what do you mean by the term isomerism. The compounds which are having the same molecular formula but different physical and chemical properties are known as isomers. Normally, isomers they are having the same molecular formula but their physical and chemical properties will be different. So these are known as isomers, and this phenomenon is known as isomerism. So under this we are going to discuss about the stereoisomerism. What is this stereoisomerism? The compounds which are having the same molecular formula but differ in the arrangement of atoms or groups in space is known as stereoisomerism. So by this we can understand that is the compounds which are having the same molecular formula. They are having the same molecular formula but they are differ in the arrangement of atoms or groups in space. So this one is known as stereoisomerism. So under this stereoisomerism we are going to discuss about the two important topics, that is geometrical isomerism and optical isomerism. So here we are going to discuss about the optical isomerism. What do you mean by the term optical isomerism? See, normally the isomers which are having the same molecular formula but they differ in the rotation of plane polarized light. This compound is said to be optically active when it rotates the plane polarized light into the left hand side or right hand side. So the isomers. So isomers we have already discussed. So they are having the same molecular formula, but these optical isomers they are differ in the rotation of plane polarized light. Then the compound is known as optically active. Normally the plane polarized light will be rotated in the left hand side or right hand side, or in other words we can tell in clockwise direction or anti-clockwise direction. If it rotates the plane polarized light into the left hand side, then it is known as levorotatory. Normally the levorotatory will be denoted by the symbol L or minus if the compound or isomer that rotates the plane polarized light into the right hand side, it is known as dextrorotatory. This will be denoted by the symbol Dr plus. Normally optically active compound it should rotate the plane polarized light into the left hand side or right hand side. If it is left hand side, then it is called as levorotatory. It will be denoted by the symbol L or minus. If it rotates the plane polarized light into the right hand side, it is known as dextrorotatory. It is denoted by the symbol Dr plus. So what is the main criteria for a compound is said to be optically active? One thing we have to remember, it should rotate the plane polarized light. Okay, and another one thing, it should contain at least one asymmetric carbon atom or chiral center. What do you mean by the term chiral center? The compound is said to be optically active, it should contain at least one asymmetric carbon atom or chiral center. So as I already mentioned that one, it should contain at least one chiral center, then only the compound is optically active. What do you mean by the term chiral center? Means for different groups or atoms that should be attached to the same carbon atom. Then it is called as asymmetric carbon atom or chiral center. Here we can find the example. This is the structure of lactic acid. To the carbon atom, 4 different groups or atoms are attached, then it is a chiral center. Here we will find that one. To the carbon atom, 1 hydrogen, 1 methyl and hydroxyl as well as carboxyl acid group is present. So 4 different groups, hydrogen, methyl group is present, hydroxyl group is present and hydroxyl group is present. So all are different. Hence it is called as asymmetric carbon atom. Here this lactic acid, it will rotate the plane polarized light into the right hand side. This one is the mirror image, another one is L lactic acid. It will rotate the plane polarized light into the left hand side. Similarly, another one example, it is the tartaric acid. Here we will find the carbon atom which contains two asymmetric carbon atoms. Here also you will find that one. This is the L-tartaric acid and this is the D-tartaric acid. Here you will find that one. Here hydrogen group is present, carboxylic acid group is present and hydroxyl group is present. Similarly here also remaining CHOH, COOH group is attached. When you take the another one carbon atom, it is also having the four different groups or atoms are attached. Hence it is compound which contains two asymmetric carbon atoms. This is the lactic acid is example for the chiral center. Only one asymmetric carbon atom is present, and tartaric acid, it is an example for the two asymmetric carbon atoms are present. This is about the introduction about the isomerism, optical isomerism and chiral center. I hope you could understand. Thank you all.